Welcome to this presentation. We have already completed our subtractors and different types of adders. Now this is time to move to our next combinational circuit that we call as the multiplexers. Sometimes you will find multiplexers written as MUX, MUX. So don't confuse yourself with these two things, they are the same. So what is a multiplexer? It is a combinational circuit that selects binary information from one of many input lines and directs it to the output line. Here you can see this thing in which there are 4 inputs and 1 output, and a dialer is there. It means you can select any input I0, I1, I2 or I3 by moving this dialer. Okay, at this position, the position you can see here, the output Y is going to be I0. If I move it here at this point, then the Y is going to be I2. So you already know that these input lines are having the data, the information of some activity, and by moving this dialer we can have a particular line carrying a particular information selected as the output Y. So why not we call it simply a data selector, because it is selecting a data. Okay, now there must be one question arising in your mind, that how this dialer is moving, how out of these 4 inputs one of the input is being selected. So it is done by a select line, or we also called it as selector variable. Okay, in this case, when we are having the 4 inputs, there are 2 selector variables required, that is your S0 and S1. S0 is the LSB of the selector variable and S1 is the MSB of the selector variable. So when the value of S0 and S1 are 0, 0, let's say this is your S0, this is your S1, then the input I0 will be selected and output Y will be I0. Very simple. Similarly, when S1 and S0 are 1, 1, the input I3 is being selected as the output Y. Okay, so I think it is now a little bit clear to you. We will see this thing in great detail in the coming presentations. So the next thing that we have to see is the representation of the multiplexer. It is represented by this rectangular box, okay, in which the number of inputs are mentioned. Let's say this is I0, this is I1, 2 inputs are there, and remember, in multiplexer the number of output is always 1. Whatever the number of input be, the number of output will always be equal to 1. This multiplexer in which there are 2 inputs and 1 output, we call it 2:1 MUX. Okay, and there will be a single selector variable S0. Okay, sometimes it is also represented like this. Okay, the 2 inputs, 1 output and 1 selector variable, 2:1 MUX. Okay, these two things, this one and this one, are the same, representing the multiplexer, that is 2:1. Now the another important thing is the relation between the selector variable and the inputs. What is the relation between the selector variables and the input? So let's say if n is the number of input and it is equal to 2 raised to the power m, then this m will give you the number of select lines, and this n is your number of input. Okay, so if I simplify it, it will be something like m is equal to log with base 2 n. So this is the relation between the number of inputs and the selector variable. So if n is the number of input, then m is the selector variable. In this case, the n is equal to 4. So let's try to find out the value of m. It is log 2. 4 can be written as 2 to the power 2 and m is equal to 2 log 2. This thing is equal to 1. So 2 multiplied by 1 gives you 2. So the number of selector lines or select variable is 2. And as you can see that I have already taken S0 and S1, two selector variables in this particular case. So this is a little bit of information about the multiplexers. Now you might be thinking that why to select one of the input out of many. There are so many uses of these multiplexers. It is a medium scale integrated circuit and it is available in the form of ICs. Okay, there are different ICs for different types of multiplexers available in the market, and by using a single IC you can implement various number of combinational circuits. Like you want to implement a half adder, a full adder, a subtractor, or any other combinational circuit, you can just simply implement it by using a MUX, a single IC. You don't require much gates in that. So there may be great advantages of doing this thing. So let's see what are the advantages of using the multiplexers. The first advantage that I have written here is it reduces the number of wires. I just told you that we don't require number of gates. You are just going to implement your logic, your combinational logic, by using a single IC. So why you are going to require more wires? Because you're not going to connect number of gates. For example, if you have to connect 10 gates, you require so many wires. And if you don't have to connect 10 gates, you just have to connect 1 or 2 gates, then you are going to require lesser number of wires. So this thing is very true in case of multiplexers. The another thing is it reduces the circuit complexity and cost. Let's see how. I just told you that the wires are reduced, and the wires are reduced because the gates are reduced. When both wires and gates are reduced, definitely the complexity is going to reduce, and at the same time cost, because gates and wires have definitely some cost. So the second point is also true. Now the third point is implementation of various circuit using the MUX that I have already explained you, and it is most important thing of the multiplexers. And when you write your exam, definitely one question from the MUX tree, that is implementation of different MUX by using different MUX, is there, and also the implementation of given logical expression by using the multiplexer is very important in your exams. So this is all about the advantages of the multiplexer. Now the next thing that we have to do is the types. What are the different types of multiplexers that we have to cover in this particular subject? It is 2 raised to 1 MUX, 4 raised to 1, 8 raised to 1, 16 raised to 1, 32 raised to 1 MUX. You can see that the output is always 1. This 2 represents the number of input lines and this 1 represents the number of output line. So the output is always 1, you can see, and I have already told you this thing at the beginning of this lecture. Now let us try to guess what is the number of selector variable in different types of MUX. In 2 raised to 1 MUX we are having the selector variable equal to 1. In 4 raised to 1 it is equal to 2. In 8 raised to 1 it is equal to 3. In 16 raised to 1 it is equal to 4, and similarly in 13 raised to 1 it is equal to 5. Okay, now the next thing and the last thing in this presentation is 2 raised to 1 MUX. Let's try to study something more about 2 raised to 1 MUX. So as I told you, it is represented by a rectangular box in which the number of inputs are shown. This is I0, I1. The output is shown. Y is the output, 2 raised to 1 MUX, and the number of selector variable will be single, so let's say S. Now one more thing is there in this multiplexer is we call E, which is your enable. Now let's see the truth table for the 2x1 MUX. This is your enable, this is your S, selector variable, and this is your output Y. Now when the value of E is equal to 0, this circuit will not work, and when the circuit is not working, the output is equal to 0. So whatever the value of selector variable, we don't care, it is always going to be 0 when the enable is 0. Now when the enable is 1 and s is equal to 0, the y is connected to I0, so y will be I0. And when the selector variable is equal to 1, this y is connected to I1 and it is equal to I1. Simple. Now let's try to find out the logical expression for this. Y is equal to what? We will see for these two cases. In this we are having E, and E is 1, so E, S is 0, so S complement, and then I0 and I0, or E is 1, so E, S is also 1, so S and then I1. You can see that E can be taken as common, so let's take E as common and we are left with S bar and I0, S and I1. Okay, and it is very clear that when the value of E is 0 and it is the AND operation, the Y is always going to be 0, that I already explained you. And the remaining thing is very easy to understand. We just write it down from the truth table that we obtained. So the next thing is the implementation of this circuit. You can easily implement it by using the two AND gates. These are our two AND gates, and the input to this first AND gate is what? S complement I0. In the second AND gate, the input is simply S and I1, and E is input to both of these AND gates, so E is there. Then we are having the OR combination of this two AND gates output, so this one is your Y. A very simple thing to do. So this is all that we need to study in the 2x1 multiplexer.